Math 102, example 3.2.4. There are two theorems that we would like to discuss in this section. The first is the remainder theorem. So we say if we take some polynomial function and divide it by x minus k, whatever we get for the remainder is the same thing we would get if we plugged that k value into our function and evaluated it. That then leads us to the factor theorem, which is kind of a bigger deal. So the factor theorem says that if I take that polynomial function p of x, it has a factor of x minus k if and only if p of k equals 0. So that sounds a little confusing, so I'm going to rephrase that a little bit. So that means k is a 0, and finding zeros is going to be a big deal for us, if when I divide p of x by x minus k, I get a remainder of 0. Now be careful, I'm dividing by x minus k, but it's k that's a 0, so there is a sign change in there. Alright, so let's say I've got the function p of x is x cubed minus 4x squared plus 9x minus 10. So, to find p of 2, that means I can take p of x and divide it by x minus 2. I'm using that remainder theorem. So I've got 1, negative 4, 9, and negative 10. Now in the box I flip my sign again, so I do just have a 2 there. If you've got the number with an x in front of it, that's when we flip the sign. However, if you've got the number by itself, as we do here, when we set up the division, it stays as is. Alright, so 1 times 2 is 2, negative 4 plus 2 is negative 2, 2 times negative 2 is negative 4, 9 plus negative 4 is 5, 2 times 5 is 10, and negative 10 plus 10 is 0. Now here I don't want the entire quotient, I want just this remainder. That should be my answer. Now for this one, let's check. What happens if I take my function and plug in 2 for x? What do I get out? 2 cubed is 8, 2 squared is 4, times 4 is 16, 9 times 2 is 18, and I've still got that minus 10. And yes, if we add all of that up, we will get 0. So, looking at our factor theorem, we can also say that 2 is a 0 of this polynomial p of x. We don't yet know the other zeros, but we know that 2 is one of them.